electric effect questions. So remember, we have Einstein's electric equation, and if we don't have frequency, we use the simple C as F lambda, and if we don't have work function, we use H as F0. Okay, very important. H, C, mass of the electron and the charge on the electron, as we'll see, are all in the pages 46 and 47. They are all constants. Okay, H and C we'll be using all of the time. Okay, so let's look at one question. So this question, this is just involving the energy of a photon. Okay, so calculate the energy of a photon of light associated with light of wavelength 554 nanometers. So let's go through. Okay, we write down what we have and we see where we go from there. So energy of the photon, we don't know. Okay, wavelength 554 nanometers. So we know that's 554 by 10 to the minus 9 meters. And don't fall into the trap putting a decimal point. It's 554 by 10 to the minus 9. Okay, C and lambda we have and we'll be using all of the time. So these are from straight off page 46 and 47. Very soon you'll know these and you'll be just writing them down. Okay, so that's it. Now that's for the energy of a photon. So we know that's the simple formula, E is equal to HF. So let's follow our usual protocol. We're looking for E, so we need H and F. We have H, we don't have F, so we have to get it. Okay, we know from the previous lesson that if we have wavelength, we have frequency. So basically we just use this formula, or extra little formula, 3.00 by 10 to the power of 8 equals frequency times the wavelength, 554 by 10 to the minus 9. Rearrange, and we get a frequency of 5.42 by 10 to the power of 15 hertz. We're now in business because we're looking for the energy. So 6.63 by 10 to the minus 34 by the frequency of 5.42 by 10 to the power of 15. Fill them in and we get an energy of 3.59 by 10 to the minus 18. Now, same system as always. Write down what we have. Write down the appropriate formula. If we're missing bits, find another formula. Okay, to get the missing bit. In this case, we're missing the frequency, so we use the C as F lambda because we had the wavelength. So that's question one. Okay, so let's look now at a question which involves the actual photoelectric equation. Right, okay, so gold is illuminated with ultraviolet light of wavelength 140 nanometers. Okay, so we have a wavelength of 140 nanometers. Straight away, we're writing down as 140 by 10 to the minus 9. And we're making our list. Work function of gold, 8.32 by 10 to the minus 19. Kinetic energy, so we'll just call it half mv squared, but that's just all together. We want that. Okay, so again, clearly, hopefully, the photoelectric effect is happening, so you write down Einstein's photoelectric effect equation. Okay, I'm putting that into brackets because it's just one thing. We're not looking for M or V in this case, that's one thing. Okay, so again, our problem here is that we don't have the frequency. You'll be doing this all the time. You'll be changing wavelength to frequency because almost always they give it to you in wavelength traditionally, and we have to make the change. So it's something you'll be doing kind of automatically. So it's the wavelength divided by the speed of light effectively. Okay, and we get a value of 1.25 by 10 to the power of 15 hertz. Okay, so we go down here then, 6.63 by 10 to the minus 34 by our 1.25 by 10 to the power of 15 equals the work function 8.32 by 10 to the minus 19 plus our kinetic energy. Right? So we get 1.42 by 10 to the minus 18. That was the energy of the photon. It needed that much energy to escape. Anything left over is the kinetic energy. So it's the energy of the photon minus the work function gives us the leftover energy, and we get 5.58 by 10 to the minus 19 joules. Okay, so clearly the photoelectric effect was happening. So we write down this equation. We were missing F because we needed half mv squared, so we needed h, f and phi. We had h and phi. We needed F, so we went and got it using our formula C is F lambda. And as I said, you'll be doing that all the time, right? We'll do one more question. Okay, so let's look at this one. Now, zinc metal is illuminated ultraviolet light, a wavelength of 240 nanometers. All so far so good. So that's 240 by 10 to the minus 9. The work function of zinc is 4.3 EV. Now, what are EV? Now, EV are a method, a form of energy measurement. It's called an electron volt. Okay, and it's a very, very small unit of energy. We have to change that to joules every time. Okay. And to change EV to joules, okay, multiply by E, which is 1.6, which is a charge on the electron, but it's just a constant number, all we need for the time being. You multiply by 1.6 by 10 to the minus 19, and this value is in, and I'll show it to you later, on page 46 and 47. So if you're in electron volts, you change to joules, and all you ever do is just multiply by E.